However, the avalanche of people who are basically said, HD more. We want to hear HD more was just extraordinary. And as a result, we have HD more, which I'm very pleased to be here. But more significantly, I had the great pleasure of listening to Michael on Monday when he gave a sort of a prelude to his discussion. And I thought the idea of internet mapping, yeah, so, blah, blah, blah. I'm saying this is one of the great changes that happen in the way I see the things. Now, we as security professionals and experts, we do have a lot of work to do in changing the environment to make it better and safer, as Michael says. But what happens when the people producing the stuff we rely on, the embedded systems, the chips, get it wrong? And I think that was the great... I left Michael's presentation on Monday and I'm a little bit disturbed. I'm not sure where we go from here, but I'll let Michael explain more. So thank you very much. HD more.
Alrighty, quick audio test. Great. All right, so I want to apologize first. I've got way too many slides for 40 minutes, and I want to leave some time for questions, so we're going to go double time. So if I'm going too fast, too slow, too boring, just throw things at me. I can dodge pretty good, and it's a good indicator of whether it's the right content or not. So I don't want to spend too much time on this as far as instructions go, so I'll just get started. So first off, my name is HD Moore. I'm the founder of the Metasploit project, going on about 10 years now. Currently serve as chief architect. I run the research team for Rapid7 as the chief research officer and the head of the labs. And if you want to stalk me online, that's my information. So HD Moore on Twitter or just hdm.rapid7.com. So this is a talk about, kind of dovetails into the last presentation about you have to really understand what's out there to know how to defend it. And we're seeing vendors do a really poor job of locking down the equipment they're selling, the equipment that they're maintaining. We're seeing ISPs providing insecure equipment to millions of people out there with no real regard for what the impact will be to those users. In a lot of cases, these are really expensive problems to fix. If you have to go rip and replace every cable modem in a small country, you're going to have it's a pretty big bill to start with, let alone scheduling and timing and so on. Unfortunately, the consumer electronics industry has got us to the point that we have no other choice in a lot of cases. We're using equipment across the board right now that has endemic flaws. That's, some of the largest exposures currently on the internet are the results of these kind of broken, supply chains. And really no concern being paid to security by these consumer electronic manufacturers. So before I get too in-depth with the data here and kind of, background of the project, one thing I do want to say is if you can't update it, you can't secure it. And when was the last time most of the folks in this room updated the firmware of their printer, of their TV set, of their Netflix player, of their home router, of their routers at work, of their Ciscos or their Junipers? And so if you look at kind of our overall IT infrastructure, there's a glaring hole in terms of what machines we don't update. And those are the ones that probably will become our largest risk going forward. So with that, I'm just going to jump into the project. So I spent a long time scanning things. So scanning the whole internet, constantly in a loop, grabbing fun data, analyzing it, trying to identify kind of what the biggest risks were out there. The mentality, kind of the mindset I went into this was, if I've only got $5 and I want to break into as many machines on the internet as fast as I possibly can, how would I do it? What vector gives me access to the most machines, the fastest, with the least amount of work? And that's the kind of that's the perspective I took when I started looking at these overall scans and the results of this research. So first off, the data that I'm talking about today is from a personal project, just scanning everything. For a bunch of reasons, it's really tough to release in whole format. However, there's some other great projects out there that do have this data. So if you want to work from the same type of data set, you can use SHODAN, which has a nice web interface, or you can download the 9 terabyte export from the Internet Census project, which we'll get into more detail on later. So if you want to follow along or want to do your own type of analysis, this data is out there, and I'm happy to answer any questions. And if you have a particular subnet you're concerned about, that you want to see if it's in my data set, I'm happy to share that as well. Just contact me offhand. So just like anything else, there's nothing new in this world. There's been a ton of these projects going back for a long time, starting with BAS in 1998, probably whoever else was doing stuff before that. We've got Metalstorm, did a lot of really cool work around the low-hanging kiwi fruit project. A lot of folks may have seen these presentations at KiwiCon 3 and some of the future work from beyond then. And there's a group in Portugal, PT Corsac, doing the same type of work as well. So this isn't just something I'm doing, it's actually what anyone can do. So I was looking at scanning the internet to acquire as much data for as many systems as I possibly could. I wanted to figure out, excuse me, let me make sure I've got a timer going here. I know we're a little short. I wanted to make sure we had basically as much data as I possibly could, the least amount of effort. So I started to focus on things like management services, 21, 22, 23, your Telnets, FTPs, things that would give me a lot of data really quickly. I also looked at a lot of UDP services, because UDP is great. You can send a UDP packet out, throw it into the throw it into the ether, and just wait for a response to come back. And you can basically hit the entire internet in about 7 hours for a single UDP packet with a really cheap low-end box. So for me, that's kind of where I focus my effort. I also wanted to get a pretty good handle on email to see what email exposures were these days, and that's really it. So how I actually did the scanning, pretty straightforward. Mmap's awesome if you know how to use it. If you actually configure it properly, you can do about 50,000 packets per second per instance, and you can run one of those per core. One thing that a lot of ISPs won't tell you is when they sell you a really low-end VPS node, you're paying $5 a month for a really crappy, 256 megs of RAM or 512 megs of RAM, but you get access to a honking Intel EE Pro card or EE Pro 1000 card. So you get these really nice network cards that have great buffering, great transmit rates. You're still only paying $5 for. So keep that in mind when you look at low-end VPS providers for this type of scanning work. And if you want to find any of the code that I'm going to talk about, it's on github.com/hdm scan-tools. For UDP packets, I had to build my own. Nothing out there really worked the way I wanted it to. So I wrote a really low CPU usage UDP blaster that just takes in data from one side and IP addresses and spews it out and records the results and does that. So the neat thing about it is you can do a /agent every 5 minutes on a really low-end machine without really using any CPU at all. It really relies on how fast your network card can pump things out. So I took all this data, normalized it to kind of a consistent internal format, threw it all into Mongo, Elasticsearch, Postgres, some JSON exports, just put anything I could to try to go through it and analyze it. I finally just gave up and did kind of ghetto map reduce, where I'm just doing pipelines in the command line with new parallel, a Ruby, PBZip2, things like that. Once the system is up and running, it's getting about 11 million new fingerprints every single day, running across 5 or 6 machines in a cluster, depending on which machines were up. And then all the processing was actually just running on boxes at my house. So it ended up being pretty cheap to run. I think total bandwidth fees were around $1,000 a month for the whole thing, even the height of the project. And the hardware and stuff I already had sitting around for the most part. So if you look at the total number of fingerprints, about 150 million unique fingerprints every month were being generated by the system that were unique in terms of data, port, and IP triplets. However, if you scan the whole internet in a loop, you annoy everybody. So the neat thing about this is I've got about 3,300 complaints. Most of that I actually had to reply to by hand. So it used about 20 hours a week for the first couple of weeks of this project just to get all the really annoying folks out of the way first. All the e-cops that went out around the world that did monitoring. I got all kinds of really crazy death threats and other types of illegal threats and so on. Had an attorney general from a state in the U.S. call me and try to put me in jail and things like that. So it was a lot of fun. In one case, it was hilarious. Right after the Mandiant report in February this year, there was a email that I received from a U.S. law enforcement agency that they were contacted by the Chinese National CERT saying, we found your APT within the U.S. and you're hacking all of our things. And of course, this law enforcement agency just emails me like, hey, they think you're hacking. Can you tell them you're not? Okay, fine. So it was kind of funny. I became like, China's APT for a brief period of time as they couldn't figure out their firewall logs. Anyways, all kinds of fun stuff out there. Someone somehow tried to insinuate I was related to Obama. I guess I hadn't seen a picture of me, but it was, anyways, there's some really bizarre stuff out there in terms of the response. One of the neat things about this, though, is after scanning the internet in a loop, annoying everybody I possibly could for 12 months straight, only 2.6% of the addressable internet was then excluded from these scans. Now, the cool thing about this is if you have a list of everybody who watches their firewall logs and can complain when you scan them, you have a meatware DDoS weapon. You can point these humans at anybody you want and take down any network with really no response. So I want to prove this out. I want to say if I spoof an attack from a victim to all these people who complain quite a lot, how long will that server be up? The answer is about 20 minutes. It took 20 minutes to generate over 500 complaints. So once you find the core of the grumpiest people on the internet, you can actually use them as a manual human DDoS cannon to take down any site you want just by spoofing attacks from whatever your victim is. So anyways, that was a fun side effect of all this, was the human DDoS element. So if you look at the total results all the way up to April 2013 when I shut it down, about 348 million unique IPs, about 12 terabytes of data, lots and lots of bandwidth. Published about 10 CVEs so far. We've got a huge backlog of all the stuff we're still working on vulnerability-wise. And all kinds of crazy stuff popped up. We kept finding government botnets. We kept finding active botnets, active CNCs, lots of stuff that really we shouldn't have found. In one case, there's a company called Gamma Group out of the UK was selling monitoring software, and they swore up and down they weren't selling it to repressive regimes, but of course we found their CNCs running at Bahrain. So they kind of had to backpedal a bit. So it was interesting to see what popped out of this research. So here's kind of the beginning of where the stats really start to be surprising. If you look at the ports that were found by most exposed IPs by service, so the far left, of course, is 1900 UDP, which is UPnP. As the previous presenter talked about, it is installed in everything. There's actually more UPnP devices running the SSDP service than there are web servers on the internet. So you look at the World Wide Web and say, okay, the World Wide Web is web. Not really. There's actually more UPnP out there than there are web servers, which is great when you want to exploit everything. If you look at the third most common service here, so if, second most common, of course, is web, port 80. The third most common is actually SNMP. So we all look at, SNMP is, something that isn't really, malicious, but we'll get into kind of some of the reasons why this is a bigger deal than it seems, and all the way down. So we'll dig into the stats here in a little more detail. Coming out to AusCERT, I've been trying to come out here for 4 years straight, couldn't make the schedule work, finally got everything lined up this year and made the trip down. It's been wonderful. Australia is great. It's been 10 years since I've been here. But one thing that jumped out is I want to see, okay, well, how different is the Australia network? How different is the Australian IP space relative to my average stats, to the US stats, things like that? If you went and actually look at the data set, it's almost identical. There was actually less than a 2% relative variance of service density in the Australian IP space versus the average for the entire world. And there's a couple things that jump up here. You see a little bit less SNMP, a little bit less NetBIOS. But it's pretty much straightforward. The graphs basically line up perfectly. The data set's different. It's been 3.4 to 3.7 billion IPs in the first set versus 48 million in the second set, but the relative values are actually pretty consistent. So it's surprising to see that the Australian IP space really is representative of the rest of the world as well. There's nothing really that's spiked out here as being very different. So with that, I spent probably 6 days crunching CPUs to figure out this answer, which is that my stats are fine, and I don't have to go redo them for Australia. So I'm happy to know that I have to redo my entire slide deck, but at the same time, it's interesting how consistent these are. So UPnP I mentioned before is a fun protocol. It's got a UDP discovery port and then a TCP control channel that speaks SOAP. And it's used for everything. It's used for Windows 8. When you plug a Windows 8 machine into the network and it automatically finds your printer, it's often doing that through SSDP and then UPnP and then mounting everything. So UPnP is being used all the time below the scenes. Even if you don't use UPnP intentionally, it's being used by everything you touch. Windows machines, Netflix players, Roku boxes, home routers, BitTorrent clients, video game systems, they all use either UPnP or NatPnP to map ports to your firewall, and it's everywhere. You actually find UPnP on non-consumer systems as well, which was surprising. We found them security DVR system, NAS servers, IP cameras, and probably the most surprising result so far is we found these Supermicro motherboards have an out-of-bound, basically IPMI card, kind of an out-of-bounds, lights-out style card to remotely manage it. Well, they've actually got an embedded Linux server running on the motherboard of these systems. And we only found out because we just bought a big batch of them to basically make Rapid7's appliances to ship out Nextbot's appliances. And right before we shipped these things out, we scanned them one more time, realized they had a second IP address we hadn't accounted for, and the second IP address was running UPnP. So our poor global engineering services guys sat there with a little pair of tweezers 8 hours straight that night, putting jumpers on the board to disable this damn thing, and while our team, of course, is writing all the exploits. So jumping into that a little bit, if you look at the top 3 vendors out there for UPnP, it's really represented by only 3 different vendors. So 63% of all the devices running UPnP are running these 3 vendors, and there's 0-day vulnerabilities for all of them as of February. Some of the vendors have fixed them, but by fixing them, fixing is kind of a strong word, because even if you fix the underlying software, there's a really low chance your specific device will ever get an update. Most of the vendors we talk to, all the big manufacturers that make little home routers, they weren't updating devices more than a year old. So if there's a remote exploit for your Belkin, your D-Link, your Linksys, whatever have you, there's a really good chance you're never going to get an update for it. It's going to be remotely exploitable, and oftentimes there's no way to turn it off. Especially in cases where ISPs were providing home gateways where the user doesn't have control of the device. They can't log into the admin settings and change stuff. Those folks are stuck basically permanently exploitable until the ISP rips and replaces that device. So that kind of goes back to the last conversation. We found almost 7,000 different products, not even instances, but products that expose the SOAP control port to the internet. This is as bad as it gets. You can just cut holes in the firewall and hack the machines behind it. It was crazy to see how much stuff is out there. So there's a whole 30-page paper on UPnP and the background to it I won't get into, but I want to jump onto the fun stuff. So Supermicro, awesome. They've got these little built-in Linux ARM box running on the motherboard, sharing the same Ethernet port as the main port of the system. And they OEM'd the solution from a company called A10, who then in turn took the Intel SDK, used that to build that UPnP support. Now, why the hell your IPMI card needs to speak UPnP, I've got no idea. Doesn't make any sense at all. However, there's about 35,000 servers out there running this thing, and there's no update from the manufacturer. You'd actually have to flash the BIOS and motherboard to be able to update these things. And as far as I know, the upstream hasn't even responded yet. A10 has not produced a patch. There's a patch for the lib UPnP library, but then A10 would have to take that. They'd have to push the update to Supermicro. Supermicro would then have to bless that in the BIOS update. That had actually got to their customers, and the customers actually have to apply it. Let's say you're a downstream customer who bought an appliance from your security vendor. You then have to find out by your security vendor you have to go apply this BIOS update. So there's so many steps involved between where the vulnerability exists and who's actually fixing the damn thing that there's no chance we're ever going to see these things updated. So you've got 35,000 servers now exposed to the internet. You can root with a single UDP packet. That's basically, you can spoof from anywhere. That gets you access to the PCI bus of a server that's probably locked down pretty well. Most of these servers are Linux or Windows. You can basically just start messing with the kernel bus, messing with the memory directly through the PCI commands built into these IPMI controllers. They have direct access to the memory of the host system. So lots of neat things out there. So about the same bug applies to about 23 million other boxes. So if you want to root things, it's a pretty good vector. Here's a Metasploit module that does a crazy ROP chain and eventually calls system to run the OpenSSL command and then shove a shell back out. The neat thing about how this exploit works is you can spoof a UDP packet to any of these devices. The device in turn will make an encrypted SSL connection out to a third-party host, and all the communication through the root shells over that SSL communication. So it's a really nasty attack from an instant response and monitoring standpoint because you can basically spoof it from anywhere and have encrypted comms as part of it. And the funny thing about it, this actually was the only realistic way to exploit it because it doesn't have Telnet installed, doesn't have a bunch of other tools installed that we typically use for this type of exploit. So it's a good example. It's been a Metasploit for a while. Have fun. So moving on to web servers real quick. Web servers really are what make the internet go round. We see web servers being everything that we do. Everything's got an admin interface on it. Everything has got a web URL, SSL interface, and so on. However, if you start looking at the stats, so the Netcraft organization basically does measuring of the internet. They look at all the domain names out there, all the different websites, to say who's running what website with what software, and they'll tell you, hey, look, Apache really has the #1 market share and has had it for years and years and years, followed by Microsoft, followed by Nginx. However, they're looking at websites, not IP addresses. If you flip that on its head and say, let's look at what the most popular web server is based on IP address, it's a completely different story. There's a software company called the Legrosoft out of Boston, Massachusetts, they're right outside of Boston someplace, I forget the actual name of the city they're in. But essentially they make an embedded web server called ROMPager. And they've built multiple versions of this thing. They built version 4.05 around 2001, 2003 timeframe. A bunch of pen testers ran into these devices, found a bunch of bugs with it, caused it to crash. It's all embedded exploitation that everyone's terrible at, but Barnaby Jack apparently. And so you're seeing all this type of research happening against these embedded devices and all these vulnerabilities. And the vendor, of course, puts a patch out and locks it all down. And the latest version of their software, I think it's like 5.5 or something like that, has pretty well locked down. Like I've done standard fuzzing tests and it looks pretty solid. However, no one's taking it. No one's actually using their code. Because what happens is they license their web server software to the manufacturers who then never bought another license for the new version. So we still have people making products today shipping an old vulnerable version of the ROMPager web server software across all these embedded devices because they already have a kit for it and they got it. I was talking to the CEO of Legrosoft and they actually came into some really weird situations where a vendor would come back to them, ask for an update, but it wasn't a vendor that ever sold their software to. What was happening is, they're selling it to a white box, so the white boxer sold it to somebody else, so they got acquired, they sold it to somebody else, and so on. And so all of a sudden, Intel's asking them for an update for a piece of software that they hadn't seen in 10 years. So it's a weird market out there, but it really all gets based in, a lot of the problems are based in the supply chain model and the way these OEMs are sourcing their software to start with. So yeah, ROMPager, if you get an exploit for that, you win. So moving on to SNMP real quick. I know I'm pretty short on time here. About 75 million devices have SNMP exposed to the internet with public as community sharing, which is pretty nasty. You can do all kinds of nasty things with SNMP. The US is the biggest offender, but they also have 1.5 billion IP addresses assigned, so no real worry on that side. You see SNMP being used for all sorts of things. One thing that's surprising about the Australian space is you see all your standard TP-Link and DSL and cable modems being exposed to the internet through SNMP, and same as any other country. But you also find a lot of these Campbell Scientific data, basically soil data loggers. So a device that's monitoring the quality of soil hooked up directly to the internet through GSM connections through one of the big ISPs here, and these things running SNMP, of course. So they're actually like the 5th most common SNMP device in Australia is these Campbell Scientific data loggers used to monitor soil temperatures and soil quality. So it was a bizarre finding. Anyways, I didn't have time to actually write it up, but I should look into that more. So SNMP read access is actually a pretty big deal all by itself. So with SNMP read access, you can monitor the system, look at the interfaces, look at data traffic, things like that. But you can actually look at the running processes, the running services, the arguments to those services. You can also look at the account names installed on Windows, the account names on Linux, and you can use these things as DDoS amplification attacks. There's probably quite a few people here who have actually been targeted by a DNS reflection or DNS amplification attack where everyone spoofs requests to a bunch of DNS servers that are open resolvers. In return, all the responses come to your victim and then inflow their systems. You can do the same type of attack with SNMP, and there's actually more SNMP servers out there than there are open DNS resolvers. So once all the kiddies figure out that DNS is finally getting locked down, people are disabling open resolvers, they're just going to switch to SNMP. And there's probably 3 or 4 more protocols out there like it as well, like NTP. So we've got a long way to go before these type of amplification attacks really are going to go away. So a gentleman named Kurt Grutzmacher came up with this really neat attack against Huawei and H3C routers. Essentially, you could dump the passwords and the password hashes of these devices remotely using just SNMP read access. The vendor eventually fixed it. It took them a few months. But of course, no one applies updates because it's a router who's going to update your router. So as part of this research, went through and basically scanned all 135,000 Huawei routers out there, sampled about 16,000 of them, dumped all their passwords. And the result is that if you try to log into any Huawei router on the internet, there's a 30% chance you can log in with admin 12345. So we talk about security in a lot of different ways, but if you can't have a non-default password, you got bigger problems. So if for some chance this doesn't work, you're in that 70% of the world where this is not the password being used in your Huawei router, use one of these. So a big pile of passwords there. These are basically the rest of them. This covers 85% of all the routers out there use one of these static passwords. So it's a pretty ridiculous result in terms of exposures. So I know I'm a little short on time, so I'm still trying to hustle here. SNMP on Windows has the same problem. Oftentimes, all the services running on a Windows machine will actually expose arguments to those services, which often contain passwords. So in the States, you actually run into CLIA equipment. Equipment used for lawful intercept actually exposes the password to the NetFlow systems that they connect you to basically sniff data and capture traffic for whoever they're monitoring. Those passwords are actually exposed in the SNMP output of these devices, and these devices are put on the internet with basically public SNMP access, no firewall. So you can see all kinds of fun passwords here. I pulled about 1,000 out of just the machines I could find. Retail, secure shell, RDP, all kinds of stuff popped out of this list. So SNMP read access is bad. So there's a gentleman named Felix Lindner who does amazing work, works for Recurity, has been doing Cisco iOS research for years and years and years and years, came up with some really awesome exploits. He did remotes for Huawei, did remotes for Cisco. However, no one else is Felix. He's basically got a monopoly on owning routers to some extent. There's other folks who've done good work out there, Barnaby, some other folks included, but really you don't see widespread remote exploits for routers happening as often as you should. Part of that's because there's so many different router models out there. You have the targeted per firmware, there's different architectures, different build flags. It's generally a pain to make a reliable exploit that work across a large set of systems. So I was looking at, well, what can I do to break into the most routers I possibly could? So I said, well, let's just try SNMP private instead of public. And that works across 17%. So 17% of those 75 million devices with public exposed to the world also respond to write access with private. 6% of all the Cisco iOS routers on the planet have private as the write string. It's ridiculous. And if you're familiar with Cisco iOS and exploiting them through SNMP, you can essentially use the private string to dump the remote configuration file from it, backdoor it, crack the passwords, whatever you want to do, and stick a new backdoored configuration file back into the device, all through TFTP and SNMP. So if you want to own lots and lots of routers, SNMP is your buddy. You can do it all through SolarWinds or whatever tools you want to use. You don't have to really hack that hard. So SNMP was neat, but I want to switch over to NetBIOS, which is in this case the 4th most popular service exposed to the internet, which is bizarre. Now one thing that's weird about NetBIOS is if you query a device through NetBIOS, it'll come back with the MAC address, the host name, the group name, and once in a while the account name. So about 50 million unique IPs respond to NetBIOS, but there's only represented 11 million unique MAC addresses, which was really bizarre. I thought MACs were unique. Why would they ever be duplicates? So it ends up a large portion of those are due to the dial-up networking adapters that are used with Huawei ZTE phones, a lot of the Samsungs, HTCs and whatnot. They basically, the software they use for tethering has a static MAC address. So that makes sense. A lot of those devices have static MACs. However, you still see a massive number of duplications across Intel-provided MACs, HP-provided MACs. All the large networking vendors you expect to have a pretty good sense of how they allocate their MAC addresses are actually shipping devices with the same MAC address multiple times across the globe. So I mean, Macs never really were that big of a security token to start with because they're spoofable and whatnot. But it was surprising to see how much duplication there actually was in the world. The fun thing about this though is if you look at the Macs that weren't part of these dial-up networking adapters, one thing you notice is that you can actually track people globally over the course of a year. You can find their laptop and it pops up in Taiwan. You can see them travel to the States. You can see them travel to Europe. You can basically track the unique MAC address across the entire world and also match against your username, their group name, their computer name to make sure you actually have the right person. So I was able to accurately track about 3 million people across the world across 12 months. So anytime they popped up in place, basically they had no firewall installed. They were getting on external segments, which was bizarre by itself. But it's pretty easy to track this. So one thing I want to talk about real quick is FTP, Telnet, and Secure Shell. So it's been 20 years since we decided Telnet was a bad thing because it's clear text. And people started actually sniffing it and attacking it all the way back to Mitnick and whatnot. So it's been a long time since we decided FTP is bad. Yet we still have more devices running FTP and Telnet on the internet than we do have Secure Shell. So Secure Shell still is a smaller portion than any of these other protocols. And if you start diving into FTP, for example, 3 vendors make up half of all the FTP servers on the internet. Anonymous FTP is enabled for about 8% of them. TLS, which is the only encryption FTP typically supports, is only supported on 15% of these total. And that's supported, not necessarily used. One of the reasons for this is all the large hosting companies still support FTP so that, random folks using Dreamweaver and other kinds of site authoring tools can upload to these systems. One thing that jumped out though, so you look at the most popular software, which is ProFTPD, and you look at the most popular versions of that software, about 2 of those most popular versions in the big pie chart off to the right are actually remotely exploitable with exploits and Metasploit. So it's crazy to see how much out there was actually exploitable. 7% were exploitable by a vulnerability identified in 2010. So something that was neat about email is, I've always thought email was terrible. It used to be send mail was a great way to pop boxes. It used to be that postfix and whatnot, where there's definitely exploits, different command filters you can do. So at one point, email was actually a great way to own things. I was going through looking at the data set, and these days it's almost all postfix for SNMP. It's almost all dovecot for POP3. And if you look at the entire internet as kind of a bar chart, you start off with the far left of this graph, which is 0, 0, 0, 0. You look at the far right of this graph, which is 255, 255, 255, 255, and each one of these little spikes is a /16, and the height of the spike is the number of email services of that particular service type in that /16. So what this tells you is that when you find one of these email services, like SNMP, for example, you're almost guaranteed to find POP3, almost guaranteed to find IMAP, but even more surprisingly, you're almost guaranteed to find the encrypted versions of those protocols as well. We're seeing a really high adoption rate for IMAP-S and POP3S, which is surprising. I actually expected to see a lot less than these than there are, but you can see these graphs almost line up perfectly. There's a couple subnets here where there's actually a big gap, so there's some dips in the encrypted services, the bottom 2, but typically they line up pretty well. So it was pretty much a non-story. Going through this entire process, I realized that people are actually using email encryption far more than they used to, and that's a good thing, at least for receiving it. One thing that was fun is playing with VNC. So it used to be that real VNC version 4.0, I forgot what it was like. I think it was real VNC 4.0.0, and maybe a version right before that, was vulnerable to authentication bypass bug. You can basically log into it, connect to it, and say, I would like to authenticate with a none protocol, and it goes, yeah, sure, why not? Let's log in with none, and then you go, thanks, and you have VNC access to the target, and that was great. So the kiddies out there exploited this like mad for years. They wrote automated scripts for it. They had all kinds of cool stuff to exploit this thing. And so I wanted to figure out, are these things still out there? Are these things still vulnerable? Ends up only 2,500 of 1.1 million VNC installations on the internet are still vulnerable to this bug. So we finally killed the bug. We finally killed one actual vulnerability, and it's not still hugely exposed. This is a huge finding just because most of the bugs you end up running into stay alive for 10 years or more. It's great to actually see us closing one of these things. And the protocol split's pretty even. I won't really bore you through results here. But one thing that did show up that was a little bizarre is in one of the banners I captured for VNC, I started getting Malaysian bank transfer documents. Just random binary stuff flying down the screen with a bunch of bank details. And I've anonymized some of it here so the names actually aren't the same anymore and the account numbers aren't real. But it's bizarre seeing random bank transfer information showing up on a VNC banner. So I telnet it to VNC, and all of a sudden bank document. It's like, that's not supposed to happen. So I was looking into it. Ends up there's a vulnerability in one of the versions of VNC out there, one of the vendors, where the copy and paste events are being exposed to non-authenticated clients. And it just happened when my scanning system connected to it, someone did a copy-paste operation, which then gave me a copy of their screen contents, which is this bank transfer. So all the stars align just in the right way for me to get a copy of this thing, but it's just bizarre what you find out there sometimes. So I want to talk about one thing that kind of my pet peeve in terms of vulnerabilities in the embedded world. There's a operating system called VxWorks that's used for embedded OS development. It's being used by lots and lots of things, including the Mars, rovers, Spirit Opportunity, whatnot. And it's got in version 5, it was very common for folks to ship this thing with a debugger still enabled on a high port. So there's a UDP port open that you can basically connect to, or send packets to, and from there you can read memory, dump memory, do all kinds of really terrible things with the device, including backdooring its password, making it auto-answer if it's a video conferencing device, just really nasty things. So we spent this huge amount of time in 2010 coordinating with all the vendors, working with about 123 different manufacturers, trying to get everyone to fix this damn thing, working with Wind River, working with the entire community to really try to put a bolt in this thing as fast as we could, because this is a pretty big exposure. We found these things exposing PLCs, exposing SCADA equipment. It was really ugly. So we spent all this time, trying to get this thing locked down, and we found about 250,000 of these things in 2010. It was like, okay, so we've got this great scanning infrastructure. Let's go scan for this thing again. Let's see how bad it is. Let's see how much we've actually improved things over the last, 2 or 3 years. It's gotten worse. Now it's now 310,000 of these things out there. And so I was like, well, maybe there's something wrong with my original scan results. Maybe they're Lin. But so you started measuring it, and the monthly average of unique IPs running the VxWorks backdoor are increasing still. So there's manufacturers out there taking these old versions of VxWorks, these old firmware builds, and just shipping more devices. People are buying more devices. So the natural growth of network equipment is kind of eclipsing the fact that some of the vendors are actually locking down their systems. So that was a surprising result of all this. So Telnet is fun because there's still lots and lots of Telnet boxes out there. About 13 million total exposed, probably a little more if I go back and look at the latest data set. Cisco routers make about 10% of the entire set, and the rest are all DSL modems and whatnot. You still see crazy old stuff like SCO Open Server, egg, Solaris, Unixware, OpenVMS is still out there via Telnet. Lots of neat things. However, if you just start scanning around, you find about 10,000 plus routers that drop you to a command shell as soon as you tell them to them. So if you want to pack like an all-star, all you do is just tell them that and you're done. It's like, that's easy. So if you control 10,000 routers or 18,000 routers with SNMP private bug, you can really do some damage to the internet as a whole. It's pretty nasty things out there you can do just based on the types of devices that are being exposed. So I anonymized some of these up here, but it was pretty scary just seeing how many of these devices were exposed to the internet. If you move on and start looking at Windows CE devices, Windows CE is that mobile embedded-ish OS that Windows uses, that Microsoft sells to system integrators, SCADA, ICS folks, as well as control systems. There's about 3,000 Windows CE shells sitting on the internet on the Telnet. And these things are connected to all kinds of cool SCADA equipment. So HMI panels, things like that. You can mess with all kinds of really fun equipment, water pumps, all using Telnet on these Windows CE devices. So they're not even trying at this point. If you move on and take a look at Linux, you find about 3,000 Linux boxes with the same thing, just shells sitting out there as root. No authentication required at all, BusyBox straight to bash, that's it. Oftentimes, actually there's a couple examples here. You'll see that UMTS, CDMA, these are actually SMS gateways in China that expose basically the entire system to the world through Telnet. So you Telnet to it, you do a PS, you see a MySQL database running, and that's where all the SMS messages are being stored and forwarded off to monitoring agencies and archiving and so on. So it's crazy seeing that there's actually these types of systems exposed directly to the internet. They're actually doing important things. Some other random stuff you find out there, license plate readers in Louisiana. So whenever you drive past a speed trap in Louisiana and it captures your plate, then the number reader actually spews the license plate number down over Telnet. So you tell the thing, watch all the cars driving by. It's pretty cool. I have no idea why, but it seems like a neat thing. So you also find the GPS tracking systems that actually give you Google Map links directly through the Telnet output. So you just click on the link in Telnet and you get cool things like this. Like, hey, look, a truck in Turkey, cool. So pop it up in Google Maps. So that I want to take a quick break and kind of go into a different topic a little bit. So I mentioned before there's a project called Internet Census 2012 where you can download lots of cool data. This is a horribly illegal project. Somebody broke into 1.2 million routers by guessing the Telnet passwords or bypassing the authentication using one of the systems we just saw earlier. And they created a command and control-less botnet that used 420,000 routers to scan the entire internet and capture all this data and store it all over a 12-month period. They published this really detailed analysis, really cool maps like this one. There it goes. So cool maps of this is where all their bots are stored. So lots of really cool data, great analysis, great research work. Unfortunately, horribly illegal. But had really cool data sets. So it's got trace routes from almost every network to every other network in it. Reverse DNS for the entire 0, 0. If you want to find every machine called exchange something on the internet, you can now. Just really neat stuff out there. So it's a great research project. Unfortunately, it's illegal in how it was generated, but small things, I guess. There's the URL if you want to find more data. So I was trying to figure out, is this thing actually real? Is this data actually a real, did this guy just make all this crap up? So I went and looked at all the MySQL scan responses from his data set, which part of MySQL, if you try to authenticate to it, try to connect to it and you're not allowed through a host ACL, it'll say IP address 1234 is not allowed to connect to the system. That's it. So I went through and looked at all the IP addresses of his scanning systems that were leaked by the MySQL responses, went back in my data set to the same timestamp before that, and realized that most of these things were running Telnet. It's like, okay, wow, this is actually pretty valid. Like nearly every single, all 94,000 of the source IPs I could actually validate as running Telnet at some point prior to them being used to scan for MySQL. So it's just way too much data to forge it, and if you actually do some one-to-ones against their data set versus mine, it's actually pretty accurate. So this is one of the reasons why I never really need to release my data set. You can download theirs instead, and it's almost exactly the same. So they did some stuff to basically prevent, production impact in these devices. For all I know, it worked or didn't work, but I'll skip on. So here's actually the concentration of devices used for this botnet. And these are devices with Telnet exposed with either admin or root as the password or no password at all. And you see a big concentration, of course, in China. You see quite a few in Australia still. No one's really immune to this stuff. And some hot spots here and there across Europe, the US, and South America. So the bot was called Karna. I think there's actually a presentation on Friday that goes into more detail on some of the stats around this stuff, so I won't go into it too much here. One thing I found when I was doing my scanning project was I kept identifying these Telnet systems that would drop straight to a shell. So one thing I'd always type in is just type history and see what was on the history for these things. And you find really crazy stuff. Ends up there's a bot called AIDRA, just a little C bot that's only purpose in life is DDoS things, and it's the one that's probably most commonly used to infect these devices. So if you ever get a DDoS attack, more than likely a big chunk of those devices are part of this AIDRA botnets, being controlled through an IRC command control system. And this is basically how they work. The attacker will scan for devices with Telnet open, log into them, spit out a bunch of wget commands that cause it to download a bunch of binaries for 5 different architectures, try running each of the different architecture binaries till one of them starts to work, and then they'll try to turn off Telnet. So you'll see the very last command of this installation script is to actually run IP tables to disable Telnet and then to rename wget. And these things have RAM file systems. So every time they reboot, they basically get flushed out and come back up again. So every time they get rebooted, you have to basically re-own them, and that's just how this stuff works. So what's surprising about this particular one is they're using FTP for it as opposed to wget. So I was like, neat. There's a FTP username and password here. Let's go let's go log into it and see what's there. So I followed that up, and I found a 1 gigabyte wtemp file and another 1 gigabyte wtemp.1 file. So these are basically the login logs, anybody using FTP to log into the system, which includes all the systems they infected. So I pulled out 1.5 million infections in 2 months out of just this one command and control of just this one botnet. And that represents about 600,000 unique IPs over this particular time frame, and doesn't include any of the HTTP-based downloaders, just ones that had FTP get installed, which are probably the minority. So there's a crap load of these bots out there. This is at least 6 other botnets I found using the same protocol, the same code base, the same method for command and control. And if you look at the stats of 13 million systems and about 3,000 Linux shells, the only reason we're seeing 3,000 Linux shells is because the rest of them have blocked Telnet. There's actually a lot more out there, you just can't find them, because they're constantly being infected, reinfected, and having Telnet disabled on them. So just to kind of wrap this up, large-scale scanning is definitely feasible, definitely cheap. For $5 a month on a VPS in Russia, you can scan the whole internet every 7 hours without using much CPU. We do have to care about Java and EBT and desktop patching, all the other stuff we worry about every day, but there's actually this other, kind of dark section of the internet that no one's really looking at, that no one's really considering in terms of the security issues. So the more effort we spend locking down, everything but our embedded devices, the more folks will target those because they become the weakest link in our security. And if you look at targeting stuff, we need to fix embedded security. We need to fix it in the manufacturing chain. We need to fix it in the supply chain. We need to hold our vendors accountable for this stuff. It's getting ridiculous. There's some mentions about the National Broadband Network earlier. We need to make sure that all the equipment that's being deployed to customers can actually be updated. People can actually maintain this stuff because it's going to have vulnerabilities. We need to be able to fix those. And if you look at the total numbers, you can probably own about 5% of the internet without really blinking if you want to min-max that and win the internet. So. I know I'm a little bit short on time here, so I'm going to go ahead and call it done. Thank you very much. Okay, so apparently we actually have time for some questions. I was going right to my endpoint, but if anyone has a question, I think there's folks with microphones walking around.
Hands up.
Oh, yes, sir?
Now, we'll just wait for the microphone. We've got one.
Okay. I can repeat the question if you like.
Hello. Doesn't sound very great for
Sorry?
the internet. Does this need legislation? Like, I mean, years and years and years and years have gone past, and software vendors aren't automatically putting automatic updates on their hardware, embedded systems, and they're not going to do it, I don't think, in the future. What needs to be done to make that happen?
We're going to have to see a really big botnet that owns everybody first. I mean, you're not going to see any kind of reaction to this stuff until there's a big enough security event that forces it. I think what's going to take, every, Telestra modem in the country getting owned at once and being, turned off for people who really care about this stuff. And we're going to see a bunch of different levels of response. You're going to start off by blocking ports at the ISP level. You're going to start seeing segmentation across the internet as folks try to block access to their vulnerable devices first. And it's going to take a really long time for the manufacturing time to catch up. So my guess is we're going to have some really nasty incident that's going to ruin everyone's day. Then we're going to have a series of, kind of knee-jerk ISP reactions to help mitigate the damage. Then it'll be 10 years from that before we actually lock down devices. At least that's my personal view.
Another question?
Oh, so look, one over there on this side looks like.
Yeah, one right over the other side.
Michael McKinnon, Big Mac on Twitter. Your comment, large-scale scanning is feasible and cheap. I presume that comment is true in an IPv4 connected world. What's your opinion on an IPv6 connected world, and how fast should we be getting there?
So if you look at V4 versus V6, in IPv6, there's only 2 ways you can discover devices reliably. I mean, you can do some guesswork here and there, but in reality, you're only going to find devices someone wants you to find. You're only going to find servers that are going to be published through DNS or otherwise linked or connected to something you can look at. And you're going to be able to find client systems by looking at who accesses your websites and actually accessing servers. So you break into servers to own all the clients, just like you do today with V4, and you look at DNS and other types of records out there to identify the servers themselves. Everything else, like all the embedded devices, all the network equipment, they're going to be really tough to identify, really tough to find, because it's, you know, even the best case scenario, it's about a 24-bit search space for a single host. And if you've got a device, any type of defense at all, you can basically look at those probes and basically hide yourself from it as it's happening. So V6 will be interesting, and it's going to basically black out the internet in terms of being able to identify systems quickly. And we'll see the same type of techniques that are being more commonplace today. Client-side attacks, phishing hole, watering hole, whatever you want to call them, they will become the norm for V6, because that's the only way to infect clients at that point. Thanks.
Okay, that'll be it.
Okay, thank you very much.
Thank you. There's something with a thank you. It was a fantastic film. Okay, just a couple of quick things before we break for morning tea. As you're aware, we'll, after this session, have morning tea, then we'll break into the visual streams. The executive is upstairs this week, so you have to be registered to go for that in advance. If you are interested in some of the stuff that HD spoke about, can I recommend that you come here tomorrow morning for Mark Fabro, because Mark will go into another level of depth that I think I was speaking to Mark about this morning, and I think he's got a great presentation that you will really enjoy as well. The other thing that HD mentioned, that in actual fact, AusCERT, we've done some own research on the Kana botnet, and we were very lucky to get some unique data that has not been available to anyone else. And we've done some rather interesting analysis of that data. So one of the Path from AusCERT will be presenting that on Friday. And I do find that if you found some of the material that HD presented of interest, you might find that one interesting as well, because that is previously unpublished and unknown. And we'll be talking about that on Friday. Again, thank you for this morning's session. Thank you for the first start, getting it off to, I think, a pretty good start. We'll look forward to the rest of the day, and I'll look forward to seeing you tomorrow morning for Mark Fabro. Thank you.